And let's see how this went. Number 1, it's tempting to do 7 minus 4 right off the bat, right?
Yes.
But that's wrong order of operations. We don't read from left to right in math typically. We read according to PEMDAS. So PEMDAS tells me to do the work in the parentheses first. So my first step would be something along the lines of 7 minus 4, parentheses. And within those parentheses, I see some exponents. So it's going to be 4 times 9 minus 4 times 8. Make sense? 3 squared, 2 cubed. Okay. So I'll keep going inside the parentheses there. I've got some multiplication now. This is 36 minus 32. Got one more step in the parentheses. 7 minus 4 times 36 minus 32 is 4. What is the operation going on in between those two numbers?
Multiplication.
Right? Because it's 4 parentheses. If there's nothing written there, we understand it to be multiplication. 4 times 4 is 16, so it'd be 7 minus 16. The only thing remaining is the subtraction that you see, and that leaves us with negative 9. Negative 9. So take a look at what you have. Take a look at what I have. I try to show some pretty clear steps, and other than my mediocre penmanship, I think it's pretty clear. You guys have any questions about any of those steps or the answer or anything like that? Okay. Very good. So number 2 then is an evaluation of an expression. So this is where we're going to be using parentheses quite a bit. So we're going to replace any variables with empty parentheses. So right off the bat, maybe it looks something like this. Square root of something squared minus something squared. Once I've done that, I'm going to replace those empty places with the numbers that go there. So this would be 10 right there and 8 right there. So that square root is kind of a grouping symbol. We're going to do the work inside there first. So within that, 10 squared is 100. Bless you. 8 squared is 64. I continue on with the order of operations. I do the work inside first. Again, grouping symbols, could be parentheses, even a square root like this is. So square root of 36, and the square root of 36 is 6. Again, any questions? Any steps unclear? I mean, even like, you know what some of the best questions are? They're like the what if questions. Like, well, what if it was different? What if it was that? How would we do this? Or what if it wasn't minus? What if it was plus? Or yeah, I don't know, whatever. Those are always great questions. Okay. Anybody have one? Nope. Okay. Finally, we get down to number 3. It says 2/3 times 1/5 plus 7/30. So this is multiple operations going on. We have clear multiplication. We have clear addition. Which one should I do first?
Multiplication.
Got to do multiplication first. So when you are multiplying fractions, do you need to have a common denominator? No, you don't. You do not need a common denominator to multiply fractions. When you multiply fractions, you simply multiply the numerators together and you multiply the denominators together. 2 times 1 is 2. 3 times 5 is 15. We still do have that plus 7/30, but that would be a pretty good first step. And then to continue on, now I'm adding fractions. Is this where I need the common denominator, or is that something else? Yes, I do. That's right, I do need it. So what would be the common denominator between 15 and 30?
30.
30, that's right. So I need to multiply the left fraction by what number?
2.
2 times the top, 2 times the bottom. That would give me a wonderful 4/30 plus 7/30. When you're adding fractions, do you add the denominators?
No.
Do you subtract the denominators? What do? Keep them the same, yep. So it's going to be something over 30, and you add the numerators. 4 plus 7 is 11. 11/30 does not reduce to lowest terms, and so we leave it as 11/30. Callie, question?
I just always get confused on fractions on which ones you change and which ones you
What do you mean by change?
I didn't mean change. I just mean where multiplication you do 30 times 5, but then addition you have to change it to the same common denominator.
That's you just said it really well. Like when you're multiplying fractions, you need to multiply the numerators times each other and the denominators times each other. Mm-hmm. You said it really well. But when you're adding or subtracting, that's when you need to do some kind of common denominator work. Yeah, you said it well. So you might feel confused, but you said it well, for sure. Okay, great question. Thank you. Anybody else? Joe.
I'm really struggling with the problems where it's a fraction with 2 sets of problems.
A fraction with 2.
Yeah, so
Can you give me an example?
So let's say negative 6, because it was the variable was times 8 or whatever, and then you have basically 1/2 squared.
So like times
Yeah, times like 1/2 squared
like this,
over 2 or something like that.
the whole thing over 2?
Yeah, it was like a problem on the homework last night.
Yeah.
It's like negative 16.
Well-
times.
Can we go over that specific one?
Yes, that would be great.
Not right this second, but can we do that?
Yeah.
Like, okay, let me do that. Is that better? Because
Yeah.
that way we can specifically address your question. This might be sort of close to it, but if we can specifically address it, maybe it's better. Is that okay? Okay. All right. Don't let me forget. We will, but maybe it'd be better just to do that exact one. You guys all get your DMRs back? Your DMR quizzes from last time?
Yeah.
Okay. If I were you, I would not toss those. You might be tempted to be like, cool, 4 out of 4, or oh man, 2 out of 4, throw it away. You might want to file those away. They could be valuable study resources for you later. Let's do this. I want to show you guys, give me 1 second here. I want to show you this. Yes, this right here. So in a minute, this will have a little bit more, a little bit more meaning to you. Let me zoom in just a little bit. Come on. There we go. Okay. So for your concept quizzes this year, which I'm about to hand back to you, guys took a concept quiz on Thursday last week. For your concept quizzes, these are going to be scored on a rubric. Okay, so a rubric is kind of a grading standard in which what I'm really trying to seek to do, what we as an Algebra 1 group of teachers are trying to do, we actually grade these together. We are trying to look and say, all right, so based on what they did with this concept quiz, what does this represent as far as their level of mastery of this material, this concept, right? And so when you get your concept quizzes back here in just a second, at the top you're not going to see a 75 or 95% or 100% or whatever. You're going to see a 0, 1, 2, 3, 4. And so the 0, 1, 2, 3, 4 goes along with these levels of understanding. So 0 means it didn't show up on the quiz and I've never seen you do it correctly in class. Make sense? In other words, at no point in time have I ever seen you execute this skill correctly. So that would be like the lowest, that'd be bad, right? Hopefully that will never be the case, but that'd be bad. A 1 means it didn't go very well on the quiz. Maybe you got like maybe 1 or 2 of them correct, or maybe you got 0 correct out of all the questions, but I have seen you do it. I've seen you do it at the board. I've seen you do it on your paper. That's one of the reasons I have you go to the board, so I can look at it and be like, you know what? They totally blew this quiz, but I've seen them do it like 15 times. You're going to get a 1 instead of a 0. That make sense? It's one of the reasons. All right, so a 1, I've seen you do it before. Maybe you need a little bit of help. Didn't go well on the quiz, you get a 1. A 2, basic mastery. Like this would be kind of the basic expectation, right? The kind of the standard expectation. A 3 means that you are where an Algebra 1 student should be, right? So like this would be, as you leave Algebra 1 at the end of the year, ready to move on to geometry and Algebra 2 and all that stuff, I can say, you know what? This person, they get Algebra 1. They understand it. They totally get it. Make sense? And then you went above and beyond. There was a challenging question in there. You got it right. Above and beyond is a 4. Make sense? Okay. So I'm going to hand back this quiz here, and I want to let you guys know that, just if you want to go back later and watch it. Okay, so we're supposed to evaluate, and we can see that we've got B's and A's, and so I'm going to put blank parentheses wherever I see those variables. So it's going to be negative, or opposite of, blank parentheses squared plus 49, blank parentheses squared plus 5, all over 2. And the A is 1/7, so that's going to drop in right there. And the B is negative 4, so it's going to drop in right there. Okay, so I'm going to do any work in the parentheses first, except there's not really work to be done in the parentheses. So I'm going to skip over that, but I've got exponents, and I need to handle those right away. So I come over here, and I can see that, whoops. Let's see here. This minus sign, this negative sign right there, not going anywhere, right? So I'm going to put this right here, but I do have this negative 4 in parentheses squared. What is that?
Positive 16.
It's positive 16, so we end up with negative 16, right? Plus 49 times, what is 1/7 squared? Isn't it really 1/7 times 1/7?
Yeah.
Which is 1/49th. Yeah, so 1/49th plus 5 still all over 2. Making sense still? There's a little bit of a trick to this one. This first 49 right here, it doesn't look like it's a fraction, but it is a fraction. It's 49 over 1. And I think writing that in might be a key. I'll kind of squeeze that in there. Now you can clearly see the numerator and denominator there. I've done the work with parentheses. I've done my exponents. Now I'm going to handle any multiplication or division that I see. And the only place where I've got multiplication going on in the numerator is right there. 49 over 1 times 1 over 49. When you are multiplying fractions together, what you do is you multiply the two numerators together. 49 times 1 is 49. And you multiply the two denominators together. 1 times 49 is 49. Does that make sense? All right. And then I do have division because of that. Just keep going down here. 49 divided by 49 is 1. And now I'm just down to addition, subtraction, and the numerator. Denominator has just been 2 this whole time. So I've really only been working on the numerator. All right, so negative 16 plus 1 is negative 16, or negative 15, sorry. And negative 15 plus 5 is negative 10. Negative 10 over 2 is negative 5 when you finally simplify the fraction down. What do you think, Joe? I appreciate you asking about that one. Is there any follow-ups or anything like that? Clarifying question?
I mean, I still can't see like where I went wrong. I mean, I understand because I can see like how you did that, but maybe I like didn't put the negative for the negative 16 and just did a positive.
Have your work to look at?
Well, I mean, like, no, I don't. I mean, I solved it on a notebook at home.
Okay.
But,
Well, go back and look at that notebook at home. You might actually, so this will be on the video. It's recording right now.
okay.
So if you go back and look at your work at home, you might be able to look at this and be like, oh my gosh, it was the negative, or maybe it was something else.
Okay.
Okay. Honestly, you could go to China and have no idea how to speak Chinese, or Russia and have no idea how to speak Russian. But if you start writing 5x plus 7 equals 18 on the board, you know what? They will understand exactly what you're doing.
What?
Yes, if you write on the board, hi, my name is Noel, and I live in Colorado, unless they know English, they'll have absolutely no idea what she's talking about. But if you get up there and start writing math, they'll be like, I get it. They'll say, I get it in Russian, whatever that is, you know. And so math really is just another language like Spanish, Russian, English, Portuguese, whatever. And so the idea here is that we want to be able to translate from Spanish to English, English to Chinese, and also English to math, or math to English. All it is just some other language. So what I want you guys to do here, start off with this set of examples here, and I just want to see if, based on the video, or maybe your past, I don't know, you can translate these 7, work together, work with each other, bounce ideas off each other. We'll check your answers in a few minutes. Let's see how this goes. Ready, set, give it a shot. This is just that first set. It says class examples. Ready, go. Guys, let me give you some answers here, see how this went. We'll eventually progress to where we're doing these at the board, and maybe a little competition here at the end. Okay. The sum of x and 9 is 12. Sum means addition. If you watched the video, hopefully that came through pretty clear. The sum of x and 9, so that would be x plus 9, is almost always means equals. It's some kind of relator. So I would go x plus 9 equals 12 for number 1. There is no need to solve. At no point does it say and find what x is or solve for x or anything like that. It just says translate. So we're translating that English into math. Any questions on number 1? All right, number 2. Quotient, very key word right there. Quotient almost, or I'd say always means divide, division, yeah. So the order matters here. So it's going to be 11 divided by y, or you could write 11 divided by y. I am definitely more of a fan of the first one, so I'm going to get rid of that second one. So 11 over y, 11 divided by y. And then this next phrase is huge, right? It's tough. Is at least. What does that mean?
Less than or equal to.
It's the other one.
Greater than.
Greater than or equal to. So if I tell you that I have at least $10 in my pocket, what would be a possibility? I have at least $10 in my pocket. I could have $11 or 12 or 20, but I couldn't have 9, right? So I'm telling you it's at least this much, means greater than or equal to. That's a tougher phrase. Any questions? Now is your chance. Please don't hesitate if you have a question. Number 3. The product. What does the word product almost always mean? Multiplication. Yeah, that's right. So 7 times b, you could use parentheses in there if you want. I'm just going to use a little dot. So 7 times b. What about decreased by? Minus. Yeah, so minus 8. So this would be 7 times b minus 8. Josh?
Can you just do 7b?
Sure. Yep, 7b minus 8. Absolutely. That definitely works. Any other questions? All right, number 4. Difference, very key word. What does difference mean in math? Subtraction. So the difference of, and this is where this one gets really complicated. The difference of what? Well, the next thing you see is a product. So it's going to be, think about it like this. It's going to be something times something minus something. This is, listen carefully, this is the difference of a product and something else, right? So we're going to be subtracting a product minus whatever. So the product is y times 4. You could just write 4y if you wanted to. And we are going to find the difference between that product and 1. So this would be 4y minus 1, or y times 4 minus 1, same thing. Please take note that numbers 1 and 2 had relators in them, like an equal sign or a greater than or equal to. Please note that numbers 3 and 4 don't. Did you notice that in number 1 and 2 there were verbs like is or is at least? Those are verbs. They give you a complete sentence. Versus numbers 3 and 4, there are no verbs. There's just descriptions and adjectives and all that. Number 5, product. The product of 12. So product means multiplication. So we're going to go 12 times something. 12 times what? 12 times what word? I'm looking for one word specifically. 12 times a sum. A sum. It's not 12 times x or 12 times 7. It's 12 times the sum. And so how do I multiply 12 times a sum? What specific symbols do I have to use, Kyrie?
Parentheses.
I have to use parentheses here. That's right. So 12 times the sum of x and 7 is x plus 7. So 12 parentheses x plus 7. And then this next little phrase, is at most. What does is at most mean? It's one of those. Less than or equal to, yes. Is less than or equal to 26. If I'm telling you the most something could be, wouldn't it have to be something below that? Right? If I said, hey, I'll give you at most $50 for this job, if I promise you that and then I give you 40, aren't I still keeping my promise? I'll give you at most 50. Well, 40 fits, right? Okay. Number 6, 15 greater than. This is a tricky one. 15 greater than the quotient of C and 9. Let me just write the answer up here. Quotient should look familiar. Quotient of C and 9 is this. 15 greater than the quotient of C and 9 is just this. Plus 15. There is, so did anybody use this symbol?
Yeah.
There's one little itty bitty word that's missing. Is. So this symbol right here means is greater than. And that little 2-letter word is makes all the difference here. If I just said, hey, I've got $20 in my pocket. The amount in your pocket is 15 greater than. Wouldn't you just take what I have and go plus 15?
Yeah.
35? Okay, so is greater than versus just greater than makes a big difference. That little 2-letter word is important. Okay, and then finally we get to another similarly tricky worded phrase. 23 less the sum. It's tempting to write less than or equal to or just less than or something. It says 23 less the sum of b and 8 is 6. So I'm going to just use this space over here. The sum of b and 8 would just be b plus 8. And 23, sorry, hang on, let me give myself a little bit more room. 23 less that, doesn't mean we're supposed to be taking the b plus 8 away from the 23? So 23 less that much, well, less, what does that sound like to you? Subtraction. But there's a key symbol that has to be in there, and that key symbol is? Got to be parentheses. So 23 less that sum. So we're taking that sum away from 23. Is 6. Is pretty much always means equals. So is or equals 6. So you see how some of these translations are ultra straightforward and pretty easy?
Yeah.
Some of them can get pretty tricky, right? Some of them can get fairly complicated. So we have about 6 minutes left, and I thought we would try one more set of these. And I think we'll save any board competitions maybe for tomorrow or the next day. So let's hold off on that. But flip over to the next page. And if you guys would, please try this set of 7.
Oh my lord.
Oh my land.
Remember, math is a language. Translating is important. Okay, take a few minutes here. We'll get through as many of these as we can. We'll give you some answers at the end. All right, so number 1, the product of x and 5 decreased by 9. This would be something like 5x minus 9. Or you could have x times 5 minus 9, something along those lines. Like that. Number 2, quotient of 12 and y. That would be 12 over y is at least, that would be greater than or equal to 26. 12 over y is greater than or equal to 26. The weight W of the truck is the sum of the weight of the engine and 1,200. So W equals E plus 1,200. I'll just do as many of these as I can. Got about 45 seconds left. The product of X and the quotient of 3 and 7 is Y. Looks like that. X times 3/7 equals Y. Number 5, the difference of 17 and the sum of X and 6 is right there. The profit P is the difference of the revenue R and 600. And lastly, 14 is less than the product of 8 and the difference of y and 5. Hey, we timed that up almost perfect. Have a great rest of your day. Don't forget there is an intro video for tomorrow. It's on algebraic expression simplification. Please do complete that before tomorrow. Have a good rest of your day.